We're actually going to roll some code. How many people here write Python code? Okay, how many write R? Cool. How many of you write SAS? Got some SAS coders in here. What I want to do is build a deep learning model for you and actually do that within the Domino Data Lab console where SAS is installed and some of our deep learning action sets. First and foremost, let's all have a great Memorial Day weekend. Thanks again for coming. The topic I want to talk about is multitask learning. And before I do that, I'm going to cover just a few things, just one slide about Domino and SAS. I also want to talk to you about what is our deep learning toolkit, what do we have, and some of the ability to use it, both actually writing Python code. So did you know that you can write Python and submit that to a SAS distributed server, something like a Volta 100 GPU, and run SAS Deep Learning? You can do the same from RStudio. So we're working with Domino and others to get our software into containers and make sure that you can use it through the language of your choice. Now, the question is, are you guys having way more fun than you ever expected already? I hope so. All right, cool. I've been waiting for this moment all day. And then I want to go over multitask learning. You know, we're going to talk about some data science today and what these models are and how you could use them. And the last thing I want to do, of course, is do a demo. So with regards to Domino, if I Alt-Tab over here carefully and actually go here, that is the Domino. Oh. Yeah, so I got to close PowerPoint? Really? Pardon? Okay. Just the extended version, correct? Now let's give it a shot. Okay. And then I'll just put it back in presenter mode. Okay, learn something every day. So this is the Domino console, and Donna DeCapite, who's here to my right, your left, she worked with the folks at Domino to get a SAS instance in there, and we created an instance called image, so you can see that at the top. And then I've actually opened up some workspaces and launched Jupyter Notebook, and we're actually going to go over some of this gory code in great detail, as much as I possibly can in 25 minutes. So the message here is that you can use SAS with containers with or without Domino Data Labs, and you can write Python code to do that. Let's go back and talk a little bit more about what we do at SAS for deep learning. And that was pretty smooth. Okay, I don't know if you lived in a cave before, but if you've been living in a cave in Virginia where I have a family farm, you know, that'd be the only person that hasn't heard of deep learning. I truly believe that deep learning is why we're talking about artificial intelligence in the magnitude that we're talking about it. It's not a silver bullet. If I'm going to do classification modeling, I'm going to build logistic regressions, decision trees, and evaluate how good those are with extreme gradient boosting or random forest. But deep learning is a Swiss Army knife. If you're going to do computer vision, object detection, classification, it's the only game in town, really. Look at the ImageNet competition. A team from China got 1% error rate. That's better than you can see and classify things. The other thing, too, is that whenever you use Siri or Google or Alexa or a SAS chatbot, yeah, we have chatbots at SAS, too. You're doing speech to text, what is that? That's a recurrent neural network. And it has, again, it really works well with time series data. You can actually use these recurrent neural networks to do forecasting. We do that at our solar farm at SAS. You know, we drink our own champagne, we drink our own wine, and we use that to forecast energy production. And we partner with Duke to share energy and et cetera. And it works out really well. Well, it also works with speech to text. That's a set of tokens in a sequence, and it's very good at understanding that. In fact, I think Microsoft currently holds the record, and it's like less than 4% error. The other thing about these models is they're big. I work with a model to do object detection for a football team in Amsterdam. Not American football, but football as in soccer. And what they were trying to do, they had an application called Bill James. And it's called Ball James. And it's named after Bill James from the Moneyball era. And what we do is we put 14 cameras in the pitch on the field. And we're running our SAS event stream processing, and we're running a deep learning model, a tiny YOLO model, which again is a hot shot, like one-shot learning model. You only look once, YOLO. Okay, that's what it stands for. And we're able to not only track the player with the ball, which is what most people do, but we track all players. And again, SAS Sports is the name of the company. They own the IP. They're a dev partner with SAS. We'd love to work with you. Give us an opportunity. And we're able to basically monitor the ball, the players, the referee, and they create the whole match back in 3D for fan experience. I don't know if you know how much these soccer players are making, but they're making as much as the guys in the NFL and the NBA, and in some cases a lot more. So they use it for recruiting. They want to find the next great Vinicius, not for 5 million, but for 500,000. And they also use it for betting and coaching. These models are big, tiny YOLOs, 50 million parameters. We fit logistic regressions, we often have a dozen or so parameters, maybe when we end up. This is 50 million. So when I say big models, I mean big models. And you got to have big compute to do it. So you run these things on GPUs, and SAS runs on Volta and also Pascal NVIDIA chips, and we write at the CUDA layer of their machine learning library and work very closely with NVIDIA to make sure our stuff is lickety-split. The other thing is you have to have big data to do deep learning. Let's not forget that. And what do you have to have? You have to have a lot of labeled data. So these cats at SAS Sports recruit college students to watch these matches and label data. They augment the data with video, so that they can, video gaming and so forth, so they can get more data. To do deep learning, it's about big models, big compute, and big data. It's not a silver bullet, but it is a Swiss Army knife. Now, a couple more things. I mentioned, what are we doing at SAS with deep learning? I already talked about the example to the top left, object detection for football players. Everybody go to wildtrack.org today and give them some money, just a little bit. Wildtrack.org. What they do, they have a program called FIT, Footprint Identification Tracking. And what they try to do is they look at lions and cheetahs and tigers and even box turtles in North Carolina. And they look at that footprint. And normally a scientist manually looks at that footprint just like the DNA footprint in your hand, and they classify this as a male leopard. What happens, Lurdy, when that male leopard gets into the, close to where people live and are farming? We got one less male leopard in the world probably that day. So it's a conservation program. Footprint identification tracking. And so with that, and that's a quarter till, awesome. With this, they actually use our deep learning to measure and evaluate those footprints, and we use it as kind of a guide to the researcher to help them classify this data as it's being collected. And if you go to wildtrack.org, you can also do some crowdsourcing. So I need to get on with the rest of the presentation. We've got a lot to cover, and I did get a little late start. We've got all the deep learning that you want. We've got RNNs, CNNs, etc. And it runs in a distributed fashion. It's part of our visual data mining and machine learning product. That's a mouthful. Visual data mining and machine learning. That's the product that you would license from SAS and get it into a Domino container. Now, the other thing, too, is that I mentioned we already do GPU compute. The thing that SAS is really good, if you take away one thing from here, is we can take that model that's big. They often have even 150, 300 million parameters. And we generate an A-store file, which is a binary file that we can shove that into our SAS event stream processing. We put it into a Basler camera with size sports, 14 of them, and we make deploying these deep learning models at the edge very, very easy. That's our big win. So multitask learning, what's that all about? Multitask, normally when you do a model, you have one label. Is it fraud? Is it not fraud? Is this a t-shirt or is it not a t-shirt? Multitask means you're going to predict multiple labels. For example, with an autonomous car, you're going to pick out things like in the road, this is a cop. This is a pedestrian. This is a traffic sign. And often, because all these things are related to the road, the features lend credibility to helping classify all these different tasks concurrently, and you end up with a better model that generalizes. Sometimes fitting these models with multiple outcomes provides, just like humans learn. You learn how to play tennis. Well, you transition to learn how to play racquetball. Well, the same kind of thing here with these multitask labels. The example I'm going to show is one to the left where the network, the DAG, the directed acyclic graphic, the architecture of the network, all of the output layers, tasks A, B, and C, share the same network structure. Over to the right, you can have soft parameter sharing. An example of how you might use multitask learning is you might want to compute sentiment, and then you might also want to do document clustering concurrently on the same data. You got two outcomes. And for time's sake, I'm going to move on to some of the other things. As I've talked about some of the advantages, let's look at our use case here. Levi's came to us, and they haven't implemented this, but they were talking to us about it. And they have some models where they build a separate model to tag what the color of the clothing is, a separate model to tag what the texture of the clothing is, okay, a separate model to classify the type of clothing. And that's fine. You could fit 3 models, but it's also a lot more efficient to build one model to classify all of those outcomes, and that's what multitask learning does. So what I'd like to do is go ahead and show you a quick demo. I think what I'm going to do is I'm actually going to show how you actually score the model first, because that's the kind of fun thing. And then whatever time we have left, we'll backtrack and we'll look at the network and how it was trained, the structure and so forth. Does that sound cool with everybody? Thank you. So here I am in this notebook. And again, I just went over here and I launched this notebook. And this notebook says, create an event stream processing project, SAS event stream processing project. And it's going to connect and create this project. And then I'm just going to check some versions. And I'm going to create a project called Multitask. Notice that this is running in Jupyter, but this is running against a Domino server where SAS event stream processing is installed. That's the key to keep in mind here. And we create this project. Now, I need to define a source window. First of all, to read in the images. That's why it says int64. It's a blob. And so we read these images into a binary file. And I'm just creating the project right now. I'm not subscribing or streaming anything yet. And I did a resize when I trained my model to 200 by 200. So just like any machine learning model, if you take a square root of a feature, you've got to also take that same transformation in image processing when you do scoring. So I'm going to, as I read in these images, standardize them to 200 by 200. Now I know you're having way more fun than you ever expected. That's without a doubt. So the next thing I'm going to do is I'm going to define this model. I'm going to create a model reader window. That's where I'm going to take this A-store model that I haven't shown you how I trained yet, but I built a network and trained it. And then I'm just going to load this model into this project. And I'm also going to set up a scorer window. And this is what my project looks like. Again, I'm going to read in the data. I'm going to resize the images in the top. I'm going to load that model into the reader window. And I'm going to spit out not one score, but multiple scores. And by the way, you can do with multitask learning supervised and unsupervised concurrently. And keep in mind, when you do multitask learning, there could be multiple labels in the same image. Okay? Now, I'm going to load this project into memory. And then I'm just going to set this up to where I can subscribe to it later. And over here, this is my actual way to publish the model. So I've set up this model, and you could define all of this in XML if you'd like, or you could come over here to one of these viewers. And this is our SAS event stream viewer, and you can drag and drop and do everything I just did in that notebook. And drag and drop and define your windows. And we have lots of windows. We have windows for doing text analytics like sentiment. We have actually doing a real-time logistic regression, not scoring, but training. We actually do things like DB scan, which is clustering in the event stream processing engine. SAS is very far advanced with real-time computing at the edge, and that is the holy grail of machine learning. We want to do continuous learning. Here I'm training a model offline, and I'm deploying it online, but we do a lot of real-time modeling. Now let's go back to where we were. Donna, keep me straight. We actually want to publish this model. I see it's 11:55, so I've got a little time here. And let's just go ahead and run all these cells. I'm just going to, basically publish this event stream processing project I created. So let's just say run all. And then what I'm going to do over here is I'm going to try to run this. And I'm actually now, and by the way, it's a little messed up because I have all of the blue dresses in one folder, and I have all the red dresses in another folder. But typically what would happen is, as someone uploads a photo online, okay, then what happens is I score it. You can see that the scores, there's blue, there's red, there's the type of clothing. I think there's 8 outcomes if I'm not mistaken. And I've put, by the way, this thing scores in milliseconds, but I put a pause in here to score this every 1.2 seconds. And this, by the way, is all running live. This is not faking it out. Okay, we're connected here, and we're running all of this stuff live. Now, what could you do with this? Well, first of all, you're doing image tagging. This is really what this application is. And people, like Belk's and Macy's and J. Crew, they do this all the time. And then let's say that I took that nice jacket you have and took a photo of you and uploaded it to something like Macy's, and then I can go back with a query and return something that looks exactly like that, just to let you know that I know what you like to wear. And then I can also get some other jackets that are very close to what he's wearing or slightly different that he may want to buy. So you can use this as a recommendation engine. That's pretty cool. So I'm not going to go over great detail. I'm not going to go over any of the modeling. I did use something called DL Pi. Now, what the hell is DL Pi? That is our own open source package that's very Keras-like. Does anybody know what Keras is here? TensorFlow is really hard to program in, right? Pretty hard. Maybe not for you, but for most of us. You look like an expert. But Keras is a wrapper that makes using TensorFlow easy. Well, you can get down and dirty with SAS. You can define your own activation function, actually, in SAS for your neural networks. But we have this wrapper called DL Pi, and you can go out. I want you to try it out. You do have to have a SAS license to be able to run the DL Pi on the server, but you can contribute to it. And the same kind of thing when I was over here running this, I was running something called ESP Pi. And that stands for the Event Stream Processing Python. Now, all of these things are open and accessible via REST. So that's the way you would probably want to hook up this application I just showed you. How much time do I have left? None? 10 minutes. Do you guys want to see some of the model training code? Okay. Well, let's look at that. It's a little bit more gory, you know, for some of you it may. Now, I did get these images from a blog. These aren't from Levi. And this guy wrote something around Keras and doing the same thing. I should have credited him, but I did not here. I may send that back out if anybody wants the PowerPoints. We have something called SWAT. This is what happens when you let developers name product stuff. It stands for SAS Wrapper for Analytics Transfer. That's a way for us to take Python code, R code, Lua. I don't know anybody program in Lua here? A little bit. We use it actually for testing, to test and validate our code. And it allows you to write in these other languages and send that code over to our distributed server and run our C code, you know, on a GPU or on a really nice Linux distributed cluster. And then I'm loading all this stuff from DLPy. But keep in mind, when I write this code, when I'm building something like a random forest, I actually return back Panda data frames also. So all those things you do to create your lift charts, all those things you do to, you know, generate reports and so forth. The concept here is you do your real heavy lifting. I'm talking about not looking at 20 features, which I've seen over and over at this conference, but thousands and thousands of features. And you're building a pretty complex model. And you can do more faster experimentation on the SAS server and then use Python for your presentation layer. And if you want to run a scikit-learn model or you want to run a PyTorch model, for example, we support Onyx. Anybody know what Onyx is? Okay, Onyx is a big deal because you want to actually be using other models rather than building them from scratch, and that's called transfer learning. And Onyx is an open source place where people from TensorFlow and PyTorch and SAS are contributing models and allows us to exchange models. And it works a hell of a lot better than PMML did. That was a total failure. By the way, if I'm doing multitask learning, I've said that these things kind of share information between one another. Like I said, you're using the same features that are based upon the road. Therefore, one feature can lend credibility to the other. You can also learn two tasks, and through eavesdropping, the third task can jump in and start learning. Now, I'm going to load something called actions. You said you used SAS before, right? Used procs, right? Those stand for procedures. Like very basic ones like proc print, or very advanced ones, you know, like our matrix factorization procedure. Now, what this allows us to do is we have action sets, much like, you know, libraries in Python. So you work at the action set level, and that allows you to kind of separate your code into like training and assessment and scoring rather than run it all in one procedure. And it allows you to be a lot more nimble. So I'm going to load these CAS actions. I'm going to load this table into memory. Okay, that's all this does. It says, here's my connection, add this library, take this data source, and notice I'm using subdirectories. So everywhere it has a red dress, all the values in that column are going to be, all the values in that folder are going to be read in and labeled as red dress. And then it's going to do the same thing for blue dresses and black jeans. And that's the way I get my labels, through reading the directories. Then I just connect to this and pull my, as I mentioned, pull my labels out with that -1. And you know, at SAS we just used to have character and numeric, and now we have, you know, basically this blob, not only for images, but audio. We do a lot of audio analysis at SAS right now. Obviously, video is something that can be broken up into frames, and you just apply deep learning and computer vision to that. So we do that. SAS, I had someone say, SAS, I thought SAS ran on mainframe. Well, we still run on mainframes, but Most of our stuff is going to be delivered through containers and on Linux boxes today. We may not be super cool, but we're still hip, in my opinion. Okay? Maybe I'm not that hip, but SAS is. And just for the hell of it, I'm not going to go through a bunch of this stuff, but let me tell you the hardest part about multitask learning. It's always the data prep. You gotta annotate that table to have multiple labels. So first of all, I'm using dummies here. And that's not SAS code, is it? That's Python code. And I'm creating dummies for these. And I needed more outcomes than this. So what is this FCMP? This is this function compiler. And that's, again, where you could write your own activation function. I'm writing some code here to compute some new variables so I can compute some additional labels. And you can see here that I'm doing things like black and jeans and denim, and I'm setting up all these outcomes because before I just had 6. And the trick of this is, once we get this all done, these are what our images look like. You saw that. We load the images into memory, then we're going to define our network, then we're going to train it, and I've already showed you the fun part. We're going to score it. Looks like I got 4.5 minutes left. That's awesome. I didn't realize that. I'm going to connect to this and do the resizing. So that's where I resized. And remember, when I deployed back in the event stream processing engine, I also resized the images to 200 by 200. You need to often rotate, crop, and do a lot of different things like that. You need to feature engineer, whether people say you need to feature engineer with deep learning, because you do. It actually extracts the features, right, and does things like autoencoders for us, but you need to prepare the features, the images. And like a puzzle, it breaks it apart. These are subcomponent modelers and progressive learners, and they look at all these edges and pieces, and they're able to come back and assemble that back into a picture and say, that's a stop sign. Now, the last thing I'm going to do here is I'm going to shuffle the data across the server, and I'm going to create my multitask model. Now, anybody know what a VGG16 model is? YOLO model. There are a lot of predefined models to where you don't have to go out, and that's the advantage of using Keras or the advantage of using DLPy. You can actually, just call one of these models without having to write out all the damn code. This one here, I'm using actually sequential, where I have an input layer, a convolutional layer, pooling, very simple network. It's not that complex. But the key to this, again, that says I'm doing multitask learning is I just don't have like a softmax at the very end to classify one label. I have multiple outputs that I created up above in that annotation table. This is the DAG. This DAG can be applied to lots of data. But now I'm going to train that model. And it shows you the network structure and all that. And this is how I train it. I define my optimization. I define, my learning rate. We also do hyperparameter tuning. We actually do something no one else does. That's called multi-objective hyperparameter tuning. I saw an ROC yesterday for churn. I would never be looking at an ROC for churn. That's ridiculous. I would be looking at something like false positives, first of all. And then I would be, also concurrently optimizing for the overall misclassification rate. That's a dual kind of hyperparameter tuning thing that we do at SAS. We just got a paper submitted and accepted at KDD, so if anybody's going to Anchorage, Alaska, hope to see you there. And then I train my network, see? So I've specified my optimization. I tell it where am I going to write my model weights, data specs. Obviously I can't go into this all in great detail, but you're all data scientists, and you kind of see what's happening. You read your data, you resize it, you define your DAG, then you train it. I have GPU equals true. Do we have GPUs in Domino Data Lab? Yes. Do we have NVIDIA, Pascal, and Volta? Yes, because that's all SAS runs on. and you could train that on a GPU. And this thing, I didn't have a lot of, I only had like 400 labels per, 400 observations per label. I've got a minute and a half. And the last thing I'm going to show you is I trained this. And you can see, first of all, looking at the loss and the fit error, things look pretty good there. I did some holdout data too, by the way, and I didn't show that, but I did take a little holdout data. Then I'm going to score that holdout data set. And you know, here's again my columns, and I get probabilities for predicted for each of those columns. And if you look at, you know, the confusion matrix for each one of these outcomes, predicted black, everything on the diagonal is correct. I'm getting very little wrong. It's amazing how well these deep learning models work. If you look at the blue, I got 3, 4 wrong out of all those observations. And so it's doing a really nice job of prediction and classification. Anyway, I kind of rolled pretty informally. Thank you for spending some time with me. I'm going to hang out outside. I've got an interview to do with the Big Data Beard guys. Anybody wants to join me with that, come on in. Have a great day, great weekend.